problem like this on Friday. We started discussing binomial distributions. What was the idea of binomial distributions? There's only two things that could happen. It's either this or this, all right? We refer to them as successes and failures, all right? And so we can write this as x is binomial distributed, and this is n and p. So you could have just a base problem that looks like that. N is my number of trials. P is the probability of success for each trial, okay? So on this one, I have my n, my trials is 6, the probability of success is 1/5. I ask you to find the probability that exactly 4 successes occur. So when I go to my calculator, we discussed this real quickly the other day. I'm going to start fresh. I'm going to go on, new. No, I'm not going to save that. And I'm going to go just add a calculator. We talked the other day that there's two locations. We're merging this idea of probability statistics. So you can go to probability, you can go to distributions, or you could go to statistics and go to distributions. I don't care which one you go. And at the bottom of the list, we see binomial PDF and we see binomial CDF. All right? What's the difference between PDF and CDF? P is precise, which means exactly a certain amount. Okay? And CDF is cumulative. So there's multiple answers there. All right? So in this case, I want the PDF. So I'm going to pick PDF. It asks me the number of trials. The number of trials is 6. The probability of success? 1/5. And the value that I'm looking for? Exactly 4 successes. All right? So I do that. It gives me my result. So my answer for question A here is 0.015. Okay? Now, the second part, part B, it says, find the probability of at least one success. Well, what are the outcomes that could work? 1 or anything bigger than it, right? Up to where?
6.
Up to 6, all right? So 1 works, 2 works, 3 works, 4, 5, 6, all those work, all right? What's the only one that doesn't work? 0, okay? Now, there's a couple different ways I could do this, all right? The easiest way, I think, is I'm going to go use the CDF function on that one because it's cumulative. We didn't use this one the other day. We talked about it, but we didn't use it. So let's go look at it. So if I went menu, and I go statistics, and I go distributions. If I go below the PDF, I see CDF. You might memorize that it's A and B, and I can just hit A and B on my calculator, and it will take me right to it, all right? And so I'm going to go choose CDF. It looks a little bit bigger. It's asking a couple more questions. What is my number of trials? 6 still. What is the probability of success? 1/5 still. Now, what's the lowest value that I want? 1. The highest value I want is 6. And it's going to take all those and add them all together. All right? So the probability that I get at least 1 success is 0.738 is what I would say. Now remember, we're rounding, and when we're rounding, we're looking for 3 significant figures. So make sure you're rounding the 3 significant figures. Now, let me discuss this again. All right? I'm going to do this one a little bit differently now. I want you to see this, what the calculator is doing. If I were to go to menu and statistics and distributions, and this time around I'm going to pick PDF. All right? Are you picking PDF because that's exact, not a bunch of them? Well, I'm going to do this a little different. I'm going to say 6 there. I'm going to say 1/5 here. And if you notice, yours says optional here, right? On that one. And so if I don't put anything in there and I just hit OK, then it gives me this as a result. That looks a little different, correct? What is this? Well, this is my probability distribution table that you did on Friday. It's all the probabilities. This is for 0. That's for 1. That's 2. That's 3. That's 4. You can scroll through there and you can get 5. You can get 6. All right. Now, the only one I didn't want was 0. So if I do 1, which is everything, minus this right there, 0.262, that's the same answer that I got here. All right, I did binomial, and I just didn't put anything in for x. So I did the n was 6, the p, I did binomial PDF, sorry. All right, binomial PDF, and so that gives me all the results. which is kind of nice if I want to see them all. All right. Last one here. I want 3 or fewer successes. So what do I want? 0 through 3. I want 0, I want 1, I want 2, I want 3. Now, could I add all those up? 0, 1, 2, and 3. Sure, you could do that. I'm going to use my up arrow key and I'm going to go highlight the CDF that I did a while ago. Now, once you've done this a few times, you'll see that's my N, that's my P, that's my lower boundary, that's my upper boundary. And I can just go in here and I can change this and make it 0, 3. If you don't like that, just go back to the menu again. All right?
How'd you get it to?
I went up arrow and I highlight it and hit enter and it brings it down. And then I can edit it. Okay? And so I do that and I get 0.983.
And so on tests, where, like, if it asks something like this as a question.
This is pretty much a calculator problem.
Oh.
Yeah. These normally, very rarely are these on non-calculator. Okay? So these are pretty much calculator problems. All right?
What's the calculators we use on the IB Math?
Yes.
Calc.
Yeah. All right, here we go. Next. I want you to read the context of this next problem, then we'll discuss here in a second.
Did you know calc stands for typing?
No.
It's like.
Go Chris, can I use the bathroom? Oh, that was on here. Guys, why did I not write that down?
Hey, just keep it to yourself.
All right.
Being mean.
Now, nowadays, when you move, you don't have to change phone numbers anymore. But let's say that you're getting a new phone number. All right. So Barbara's getting a new phone number. She gets her phone for the first time. Has her line. She's got a couple of numbers that are her favorite numbers. 2, 3, 5, and 7 are her favorite numbers. Anybody know what's in common with 2, 3, 5, and 7? They're all prime numbers. That's what they are. All right. Those are the prime numbers. So she likes prime numbers. She wants these numbers to be in her phone number. All right. And so we want to find the probability distribution for these. Now they have the table set up for me. So if there's 4 numbers that are going in my phone number, because I can't pick the area code, it's already there. All right. But I can pick the other 4 potentially. And so what's the probability that I have a success, that she has a success? She gets one of her numbers. 4 out of 10. Well, not 4 out of 9. Because you got to have the 0, right? Look at your digits on your phone or whatever. There's 10 numbers there. There's 10 digits. 1, 2, 3, 4, 5, 6, 7, 8, 9. But don't forget about 0. All right? So the probability of success would be 4 out of 10. If you'd like to reduce that to 2/5, that's fine. So the probability of success would be 4/10.
Wait,
All right?
wouldn't it be 11?
Why 11?
So you have 3, 3 and 4, and then plus 1. You're like the.
No, there's just 10 digits.
No, silly, it's 10.
Where are you getting the 11th digit?
It's 0 through 9.
You using 10? All right. Now, here we go. There's 10 digits. Now, 4 out of 10, there's 4 that I like. 4 out of 10 is the probability of success. Now, if I do this, if I pick a number, and a lot of times it's generated at random, what's the probability that I get none of my numbers, 1 of my numbers, 2 of my numbers, 3, and 4? All right? I'm going to use my calculator to go build this probability table, all right now. So I'm going to go do what I just showed you in the calculator. I'm going to go menu, probability distributions, and I'm going to go use binomial again. All right? How many trials do I have?
4.
4. There's 4 numbers that I'm choosing. All right? There's trial of 4 numbers. The probability of success is 4 out of 10. All right? And I'm going to leave that optional again. I'm not going to put anything there. All right? So I'm going to hit OK. Now, let me slide this over because I'm going to copy this into my table. All right? And so if I were to do this 0.1296, that's the probability that I get I have no successes. The 0.3456, that's the probability of 1. Happens to be the same thing for 2. And then 0.1536 is 3, and 0.0256 is 4. All right? So had we known about this on Friday, we could have used this to be able to help us create a probability distribution table. Okay? Everybody all right with that? Now, it states this. So we've made the probability distribution table. What is the expected number of prime digits in the value? So what's the expected value? So this is page 570 from homework. All right? How do we find expected value?
Wouldn't you add all the probabilities together?
Don't add them all up yet. Multiply them first and then add them all. So 0 in this is going to be easy. That's 0. 1 in this is going to be easier one. So 0.356. I'm going to multiply there. And if I'm not mistaken, that's 0.6912. If I multiply here,
Yo, how'd you do that in your head? That's the real question.
was that right?
Wait, what are we multiplying?
No,
Point 0.1536 times 3.
It's 0.4608.
4608.
Yeah.
Okay.
Wait, why 0.153?
That's what the calc says, though.
0.1536.
Okay.
Ah.
Times the 6.
What's 0? This 0 times that. So we're multiplying these together. We're multiplying in the table. You said it's 0.47 what?
4.4608.
0.4608.
Yes.
Okay.
According to the calc.
So wait, we multiplied the 1 point, or
It is. It's 108.
0.1536 by,
Yeah. And then this last one is 0.1024. Yes.
yes.
Okay.
Ah.
All right. Everybody all right with that? Now this is definitely a calculator problem because that would be a little bit. I'm not worried about you multiplying all that out by hand. I'm gonna add all that up now. Okay. So I'm gonna take all these pieces and I'm gonna add them all together. When I add all those up, I get 1.6 is what I get. Okay? On the dot. It works out pretty well because this is 10, that's also 10, so that's 20. Do that there, and I got 2, 1, and 2, plus 5, which is another 10, so those are both zeros. Add another one there, and I think that's also 20. All right, and then I add up there and it's 16. And so it worked out pretty evenly there. Now, let's discuss this. What does this 1.6 mean?
Is that the expected number?
That's the expected number. That's the expected value of how many digits she's going to get that are her favorite. All right. So on average, she would expect, if I did this multiple times, she would expect to get 1.6 of her digits that she likes. All right. Close to 2. All right. But she can expect to get 1 for sure, maybe 2, is what I would say there. Okay. Now, on your formula page, you have another formula. All right. On the formula page, you have this. You have expected value, E of X, is equal to N times P. N is my number of trials. P is the probability of success. Do we know how many trials are in this problem?
4.
4. Do we know the probability of success?
Yes.
4/10. So if I did this, 4 times 4 is 16. 1 times 10 is 10. What's 16 divided by 10?
Yo, why didn't we just do that?
Because we can do it both ways.
Yes.
Hello?
No, she's not. Or no.
I'm sorry.
Keep it to yourself.
Yeah,
give him
You was the one making awesome sounds.
And so why did we do that? Why didn't we do that first? Well, here's the thing. You still need to know how to do this. If I don't give you a probability of the number of successes, or excuse me, the number of trials and the probability of success, if I don't give that, we have to use this to find expected value. If I give you the number of trials and I give you the probability of success, then this is our shortcut. Okay? So not every time will they give me that.
How
all
are
right?
you supposed to find expected value if you don't know the number of trials?
Then we have to build that table and we multiply. That's what we did on.
And we just keep going until what number?
We would probably.
You don't know the number of trials?
Yeah, we don't know how many times that we're getting there.
Yeah.
All right.
You wouldn't.
But that's kind of what we did on page 590 from the other night. We didn't have the number of trials, we didn't have the probability of success. All right. So if we go to the next one,
Stop it. Alright.
so you got a basketball player. She takes, she has a 3/4 chance of scoring. In a particular game, she takes 20 shots. How many shots would you expect her to make? Well, do I want to draw a probability distribution table from 0 to 20? I don't really want to do that. Okay.
It is not Angel.
And so this right here, expected value is n times p. So 20 is my number of trials. That's number of shots. Probability of success for each trial is 3/4. And that is, many of you already said that's 15. So on average, I can expect this person to make 15 shots. Okay. Everybody good?
Yes, sir.
All right, here you go. Read this next one. This one's good context after Halloween with all the candy around your house.
A pack of Smarties, that was 10 Smarties in it.
You're basically writing with your nose like this.
Like,
Okay, can I just do this in the couch?
yeah, like,
Yep.
Is it like the magnet one?
All right. I'm not sure, but in our house, when we get all the Halloween candy and stuff like that, we kind of divide it into candy that we like and candy that we don't like. This is one that gets in the not like candy category for me. I'm not a Smartie person. Y'all like Smarties? Okay. Right. Just straight sugar. I almost would rather eat chalk. All right. Now, here's the deal. In each little package, all right, there's 10 Smarties in each package. The probability of getting a red Smartie on average is 0.4. The probability of getting that is 0.4. What's the probability of getting at least 3 red Smarties? Now, I don't think I have your full attention. Got it? So the probability of getting at least 3 red Smarties. I could get 3, I could get 4, I could get 5, I could get 6, I could get all the way up to 10. Any of those would be choices. What does that sound like to you? Which one am I going to use? PDF or CDF? CDF. This is a CDF one, okay? So I'm going to use CDF to answer this question. All right, so if I go to my calculator, I'm going to go menu, and I'm going to go statistics or probability, either way, go distributions. I'm going to go binomial CDF, okay? Number of trials. There are 10 candies in each little package. Probability of success is 0.4. I want 3 or more, so I'm wanting 3 to 10. Okay? I hit enter, and it has done that for me, except it didn't enter it. Let me try that again. All right? So statistics, distributions, CDF, and I got 10, I got 0.4, got 3, and I got 10. All right, there you go. 0.833 is what we'd say here. Okay? 0.833. Is that what you got?
Yes.
Okay. Now, next it says, what is the expected value? All right. What is the expected value? So if I grab a package of Smarties, how many red ones should I expect to get? All right. I should expect to get 4. All right. Expected value is n times p. Do I know the number of trials? 10. Do I know the probability of success? 0.4. And if I were to multiply that together, that gives me 4. That is correct. Okay? So on average, there I would expect to get 4 red Smarties in each package. Okay?
is
No,
the
they do. They're all
probability of
very
getting
similar.
red Smarties
Alright.
actually
I
0.4, or
don't
is it
think
just made
there's
up?
any different
Oh, no.
flavors in this.
No, they may not be. They just put different dye in it.
Smarties are
Okay.
white one is different.
All right, here we go. This is what I'd like you to do. Turn page. Or is it flip the packet over?
No, it's like
No,
Oh,
it's
it's
right
on the other
here.
side. Okay. I want you to try the first 2 or 3 problems on this one. So try these on your own real quick. We'll go over them here in a second.
Can I go to the bathroom quick? We saw like a whole bucket.
All right, we're working on this problem. Let's go. Let's see if we can get.
Would this be a CDF?
First one?
Exactly.
No, there's gonna be different pieces.
The first one be a CDF and then it'll be a PDF.
Because what's it asking for?
Oh, exactly.
It's only asking for one result. That's PDF.
Coach Rice,
Yep.
in the equation, what is the E of X stand for?
The expected value.
So what would the expected value be in this?
And this right here, expected value, this is I take the number of trials, which would be 10, multiply it by the 0.72. That's the problem is this. So it didn't ask me for expected value here, but expected value would be like 7.2.
No, wait, so what? No, the number of trials. The X would be.
And then what is the NP?
A is the number of trials. P is the number of probability of success.
Calc.
Yes, just got it.
Coach Rice, for the first one, it would be 0.18, it would be the
Yeah.
So it'd be 0.18.
Yeah, because it went round.
And for the second one, is that a CDF? Wait, so would X value be exactly 6
Say again?
for a binomial PDF?
Yes,
X value
yes, it would be
6, yeah, that's what you're looking for.
It's not CDF? So Coach Rice,
Oh,
would the
yeah.
one with the lower bound be 6?
Yeah.
No.
All right, take about 30 more seconds for your over.
Is the third one a PDF?
No.
Hey, stop stealing my answers, Chris.
Yeah, you can do it that way. No, the top one's not 6, the top one's 10. Because that's how many people I'm asking. So if I ask you, your trial, if I ask you, your trial, if I ask him, your trial. So those are my trials, so 10 people I asked. Now you got all of them, so if you could put, you did the optional, I put it, I'm gonna put 6 in the X, because that's what I'm looking for, 6 people. Then it will give me the exact one, instead of having to sort through all the answers. We're gonna do it. All right, here we go. Let's take a look. So 72% of union members are in favor of a certain change in their contract. I choose a random sample of 10, and then I want to know this right here. All right, so this first one, the probability that exactly 6 members are in favor of the change. What is that?
0.18.
What am I going to use?
PDF.
PDF. All right, I'm going to use PDF on that one. The N, the number of trials is 10. The probability of success? 0.72. Could you use 72 over 100?
Yes, sir.
That's percent there also. All right, and the X that I'm looking for is
6.
6. All right, that gives me a result of
It was like
0.180. That's my 3 significant figures. All right, it's 0.1796 or something like that. Round up to 3 significant figures. So there it is. Okay. Next, what am I going to use on the next one? At least 6 members are in favor.
a CDF.
That's CDF. Okay. So N is 10 still. P is 0.72 still. My lower
6.
and my upper.
10.
Okay. So 6 and 10. Now, if you're doing a problem like this for homework and you're going, I don't have a calculator, can I not do this?
You can.
All right. That's how I do that, and then I can go put that in the calculator when I get back to class or whatever the next day. All right. This right here gives me a result of what?
0.88.
0.88.
0.882, I believe.
I just got 0.88. It was like 0.79.
Yeah.
It was 0.8818.
Yeah. So 0.882, I believe, was what I got. All right. Now, how's this one different?
It's asking like at most.
At most,
So would the lower bound be 0 and the upper be 6?
lower bound would be 0, upper bound would be 6. What if it said less than 6 members?
Then 0 to 5.
0 to 5. Just make sure you're reading carefully, okay? And so they have that from time to time, okay? And so I would put this in there, 10.7206, and what did you get for this one?
0.297.
29, I think they're 7 rounded up, right?
0.3.
0.298.
0.3.
Okay. You can put
Yeah,
it if
we
you'd
get
like.
points off.
Yes. 3 significant figures. All right. 3 significant figures. All right. Here you go. I'm going to stop right there. We've got about 7 or 8 minutes left. I'm going to put a couple of problems on the board. The 2 deals. Use your calculator and work the problems.